In this video, I'm going to explain how to use right triangle trig to solve for a missing side in a right triangle. And here I have a diagram given to the left of just that, of a right triangle here, and I have the measure of one of my acute angles of 35 degrees. And then I know the value of one side length, and then I'm missing the value of this second side length. So using right triangle trig, sine, cosine, and tangent, I'm going to be able to use one of those three trig functions to solve for this missing length x of my triangle. Now, I can use these three trig functions because I do have one acute angle and one side, so I am able to use these trig functions. Now, in terms of which one to use, I'm actually going to revert back to the abbreviations in which I think of when I hear these words, sine, cosine, and tangent. I think of the abbreviation SO, CA, TOA. And again, this abbreviation helps me remember which ratio of sides go with which trig function. Now, given this triangle here to the left, this is my angle of 35 degrees. This is the angle in which I label and consider the other sides of my triangle. So if this is my angle of 35 degrees, the leg that is touching this angle or is next to this angle is labeled as my adjacent side. So 8 is my adjacent side. And then now we already know what this side is called. This is the longest side of a right triangle. It's opposite this right angle. This side in blue here, this is my hypotenuse. Now, I neither know the length of this hypotenuse nor am interested in actually finding the length. There's actually nothing that I'm concerned with this hypotenuse, but nonetheless that is labeled the hypotenuse of my right triangle. Now, this missing length of x in which I am concerned about finding and that I am solving for, this is the side in the leg that is opposite the angle in which I have. So this side x I consider as my opposite side. So because I have both the opposite and the adjacent side, I'm going to be using the tangent function. Again, I don't have the hypotenuse of my right triangle, and I'm not even being asked to find it, so I'm not using the sine, the cosine functions. I'm going to use this tangent function of this acute angle. So this tangent function, the tangent function of 35 degrees is going to be equal to the ratio of the opposite over adjacent sides of my right triangle. Now my opposite side is x, in which I'm solving for, and then my adjacent side length is 8, the one that I know. So here, doing my trig setup, and again, this is my trig setup. The trig function tangent of my acute angle 35, so tangent of 35 is equal to my opposite side x over my adjacent side 8. So this is my setup. Now from my setup, I can solve for this missing length of x. So here, identifying that x is being divided by 8, and I'm solving for x, I'm using inverse operations to find the value of x. I'm going to multiply both sides by 8, which undoes the division. So here I have the product 8 times the tangent of 35 degrees, and that's equal to my x value. Now you can pause the video if you would like and use your calculator to find that value. Okay, now after finding the value of this on your calculator, again, make sure that you are in degree mode on your calculator. But the value of my missing side x is 5.602, rounding to the nearest thousandth. So again, this video is just explaining which trig function, sine, cosine, or tangent to use, given the information presented to me on this triangle. And I used my tangent function because I was given both the opposite side and the adjacent side. After my setup, multiplied both sides by 8, which gives me the length of my missing side to be 5.602.